Meetup is an online service that allows people to gather into groups and meet in person. Since 2002, the company has been growing and its technology stack has been changing. Today, they are in the process of migrating to the cloud, using both Amazon Web Services and Google Compute Platform. Yvette Pasqua is the CTO of Meetup, and she joins the show to explain how Meetup's technology stack works and how the teams are organized. The discussion of multiple clouds is particularly interesting. Yvette describes GCP and AWS as both having distinct, well-defined use cases at Meetup. So if you're considering a multi-cloud architecture, this may be an appealing episode to you. There's also plenty of interesting discussions about how Yvette manages teams at Meetup as CTO. And as a side note, the first Software Engineering Daily meetup is happening January 11th at Galvanize in San Francisco. I would love for you to make it, and if you want to find out more, you can go to the Software Engineering Daily website or the meetup page for Software Engineering Daily. Every software project uses email. Every time an e-commerce site processes a transaction or a user makes a comment on a social network, email notifications are sent. SparkPost provides email delivery services for apps and websites. To try SparkPost and send 100,000 emails a month for free, go to pages.sparkpost.com/sedaily. SparkPost has a range of pricing options, from free self-service packages to sophisticated enterprise support and services. Start sending emails to your users today. Go to pages.sparkpost.com/sedaily to send 100,000 emails a month for free. Thanks to SparkPost for being a new sponsor of Software Engineering Daily. And if you want to send 100,000 emails a month for free, go to pages.sparkpost.com/sedaily. Yvette Pasqua is the CTO of Meetup. Yvette, welcome to Software Engineering Daily.
Yeah, thanks so much, Jeff. Really, really excited to speak with you.
Meetup is an online service where people can gather into groups and meet in person. The company is, I think, 14 years old or so.
Really, really good estimate there. Yeah, we'll be 15 in February.
Can you give me a high-level view of the software architecture as it is today?
Sure. And that's somewhat of a debatable question because we're actually replatforming many of the different parts of our software stack. So if it's okay with you, I can tell you a little bit about what we are. A few months ago today, and what we've started to launch as far as new parts of our stack and new parts of our platform. Is that interesting? Yeah.
Yeah, absolutely.
So, at its core, Meetup's been a JVM shop since the beginning times, and from a back-end perspective, also a MySQL shop. We're currently running on 2 bare metal data centers, one in New York, one in Philly. We're actually really, really close to moving to the cloud. And I say the cloud kind of with a little bit of pain inside because I hate using that term, but more specifically, we've actually already moved our data pipeline to Google's cloud platform, which we've loved so far. We're also launching and have launched without production traffic yet some initial services, some backend core platform services to Google's cloud platform running on Kubernetes, which we've also loved working with too. But the main part of our backend is still a monolith that's running in our data centers. And in the next few months, we'll be sending more and more production traffic to an Amazon Web Service built on EC2. And we're actually using Docker containers on EC2 now. that'll be running our applications very shortly. So from a back-end stack perspective, we were MySQL. Now we're using Amazon's Aurora as well as Google's data store. I might get some of the Google product names wrong because their product names tend to be very generic. So like data store, right? I'm pretty sure that's it.
That's like the S3 equivalent, I think.
No, that's their name value pair database. So it's kind of like the Cassandra, the managed version of Cassandra that Google has. Again, I might have that product name wrong, but I think it's right. And as a JVM shop, we started off writing most of our backend core part of our product in Java. The last couple of years, engineers here have really loved working with Scala, and very close to 100% of the new code we've been writing has been Scala, so we're somewhat of a hybrid there. We have some legacy stuff on the web side written in Python, but we're moving our web stack to a 100% JavaScript stack as well. We used to use, like I said, JavaScript and Python, a little bit of Backbone, somewhat of a hand-rolled framework. We now just started launching new parts of our web framework, and some pages will be using that new framework live very shortly. It's built on React and Node and the React ecosystem of things, for example, Redux and a lot of other.
So you've already mentioned a lot of different aspects of the architecture that are pretty interesting. Let's start with the JVM part, and you've got this big JVM monolith. It sounds like what kinds of architectural changes or augmentations have you had to make to that JVM monolith to put it in a position where you can break it up into things you can put on Kubernetes or move off of the data center? Or what are because I think a lot of people are listening who are probably in a similar situation where they've got a .NET monolith or a JVM monolith and it's running in a data center, and they are thinking, how should I modularize this and how should I move this to the cloud? It sounds like you have already kind of done the preliminary architectural decisions, but maybe you're in the process of implementing that.
Yep. Great questions. And we had the same questions. We started this process in January of this year. We had the same questions, brought in a lot of people, some of whom have already spoken on your show in the past, and really asked them similar questions. So happy to share the knowledge that was passed along to us. So we've actually had a few different things going in parallel. The first one is we knew that we wanted to move our monolith from our data centers to the cloud. No matter how quickly we were able to actually break that monolith into pieces and deploy it as services. In speaking with companies who have done this before, you name it, really big ones, really small ones, there's not a single company I've spoken with who doesn't still have part of their monolith hanging around without a potential of it going away anytime soon in 2 to 3 years, right? And often much longer for companies who've done this several years ago. So we learned from that we likely are going to be like every other company out there, and we should treat our monolith as if it will be something that will be evolving into a smaller monolith, and eventually probably remain something like an Uber service or I don't know how you'd want to call it, right? So we knew moving it from the data center to the cloud would be important, and it wouldn't just be an ephemeral thing. It would be a pretty long-term thing, at least long-term from a internet tech perspective of 3 to 5 years. Some things that we started to do from a application and really more our systems infrastructure team perspective was to take a look at all of the technologies in our stack we prototyped on both Amazon and Google's cloud platform with two different use cases in mind. The first one was, how do we move our monolith over fastest and best? The second one was, in a new service-oriented world, what platform is best for us to deploy and manage those services, especially in a world where we're moving much more to our software engineers owning those services end to end and really empowering them with tools to do that. Our monolith has very, similarly with other companies, I'm sure, has been managed by a smaller set of systems engineers who used to be called technology operations folks, as well as some of our software engineers who are more of a DevOps on-call team, and they rotate through on-call rotations. So we didn't intend this, by the way, but we ended up choosing both Amazon and Google for different reasons. So we chose Amazon to migrate our current monolith onto because of the really strong number of managed services that they had. Essentially anything that we wanted to do, Amazon had a service for it. And we saw that as a big win. We no longer want to be treating every part of our application as this unique snowflake. We really wanted to start treating as much of our application as a stateless, and then I forget who coined this term. It certainly wasn't me, but there's cattle and there are kittens, right? And there are cattle servers which are stateless, and they can crash and burn, and you can spin them up again. And we wanted to move as much of our application to that as possible, so that we could really write code to deploy infrastructure and not worry about state. And then we knew that because this was a legacy application, there were some things we had to treat as kittens, but we tried to minimize that as much as possible. So for cattle things especially, we looked to find Amazon services that we could migrate to. It was much easier than we thought, even though, of course, the marketing documentation makes it sound easy to migrate, for example, from MySQL to Aurora. We've done the full migration. We're about a week or two away from testing our AWS infrastructure with some production traffic, but we've pretty much done it in 6 months at this point, which is quite fast. We were really aggressive. We were really bold. Our systems engineers and the software engineers and SREs working with them put together an aggressive timeline, and we think we were able to do it as quickly as we were because of that strategic vision that our director Alessandro had really pushed with the team, which was use managed services wherever we can, treat things like cattle. Let's try to treat as much as we can as stateless. We're using CloudFormation to build our infrastructure as code. And for all the other things, let's treat them as one-offs, right? So we're really close to getting there. And Amazon themselves, frankly, their customer service, they even paid for an engineer to sit at our office for about 10 weeks and hands-on help us with this migration. They've been great, and we felt like we'd really be able to do it faster if we moved our monolith to Amazon. On the other side of things, our data pipeline and our new service-oriented architecture, we prototyped both of those things on both Amazon and Google, and we decided to go with Google for those two pieces. So we didn't expect to kind of be a hybrid, but we ended up being a hybrid. We picked Google for our data pipeline because we really, really strategically liked where their data services were going. We also, in our tests at least... Are you
talking about like Dataflow and Beam?
Yeah. And even BigQuery, Bigtable. The performance of those services we saw as better, and we've spoken with a few other companies who in their tests, they saw the same thing. As things like being able to use Google PubSub were really exciting to us instead of maybe having to keep our own Kafka kind of hand-rolled thing. So we looked at performance, we looked at the big data, the pipeline services that they had, and in doing a cost comparison, and we won't really know until we go live, it looked like Google would be a little bit less expensive for us from a data pipeline perspective. So
now, okay, so the data that you're throwing into the data pipeline,
yep.
I'm guessing that is quite distinct from the types of user data that you have on Amazon. Because I think
Exactly.
about Meetup, and it's like if I'm running a Meetup, there's really not a whole lot of data involved in my user account. Like there's who I am, my meetups that I'm signed up for, maybe the meetups that I'm organizing, the people that are signed up for those meetups. But then you have all of this,
analytics, tracking data, right?
Analytics, exhaust data, this stuff that just is not. It doesn't really have an effect on my usage of my own account, but it is the stuff that you will use to I don't know, train machine learning algorithms or do analytics and stuff, and so you're siphoning off all of that stuff into Google. Does that lead to any duplication, or is it mostly, are these disjoint sets of data?
Those two lines are pretty disjointed sets of data, where we're actually in the middle of building a new split testing system, and those will probably bring them together, right? So once we'll probably be collecting the data in Google, maybe we're always running our ML algorithms on top of that, but in the case of split test testing, we may or may not be doing that within this system itself, using those as a service. But then being able to either automatically or manually put users back into the right split test groups and serve them the right content. It's kind of where split testing tool becomes somewhat of a segmentation personalization tool. So we imagine that will actually touch both data sets. But as it is right now, they're actually quite separate. And that was that's a generally good thing from our perspective, from an architecture perspective, because our analytics pipeline, we really want to be all about efficiently using cloud resources to collect as much data as possible. And then we're using Looker on the front end to display that to all of our internal folks to make business decisions on. And like you said, we have the separation where all of the user data, all of our PII data, or even non-PII user data, like what groups you belong to, what meetups each group has created in the past. They have descriptions and times and number of RSVPs and all of that. That's all sitting separately in Amazon right now.
When I'm choosing the tools for my side projects, the first thing that I look for is ease of use. That's why I love MongoDB. It is the most popular non-relational database, and it is super easy to use. At the beginning of a project, I often don't know the shape of my objects, and Mongo makes it easy to evolve the database schema as I like over time. Over time, as my project gets popular, I'm going to need to scale, and thankfully, MongoDB has built-in horizontal scalability, but configuration and database maintenance aren't really what I want to spend my time on. Thankfully, MongoDB Atlas was released in 2016. MongoDB Atlas is the easiest way to get access to MongoDB without having to run the database yourself. You pay only for what you use, from small projects all the way up to large production deployments. To try MongoDB Atlas today, go to mongodb.com/sedaily and get a free $25 in credit. Use promo code GOATLAS25 to get that $25 in free credit. Atlas is the only hosted MongoDB service built by the engineers behind the database, the company MongoDB. With Atlas, you get end-to-end encryption, you get VPC peering, you get access to the latest releases, and for a limited time, you can go to mongodb.com/sedaily Enter promo code GOATLAS25 and get that $25 in credit and get started with MongoDB Atlas. Thanks to MongoDB for being a new sponsor of Software Engineering Daily, and thanks for being the database behind a lot of my favorite side projects in the past. We're really happy to have MongoDB as a new sponsor of Software Engineering Daily. It's interesting you mentioned Looker. That brings to mind this show I did a while ago with Tomasz Tungus, who wrote a book called Winning with Data, and he works at a venture capital place that actually invested in Looker, and I think he co-wrote the book with the guy who started Looker. And so one of the things they talk about is like the silos that prevent organizations from sometimes getting the most out of their data. Just basically the idea that if you are somebody at a company, if you're a product manager at a company and you want to know what feature to roll out next and you don't have proficiency in data science, you have to go to the SQL expert and say, hey, can you drum up this data for me? And then the data scientist has, or the SQL specialist, whoever it is, has to go and spend time doing that query. And there's often what Tomasz called a data breadline, where you have these people who are waiting in line to get their queries interpreted and answered. And I guess Looker was some technology that was created kind of to try to shore up that problem. But this seems like the type of issue that would be core to getting Meetup to run as you would like it to, because it's a user-facing piece of technology, and you have all this exhaust data. Can you talk some about how the teams are organized in terms of data engineering or data science and feature requests, and how you solve those types of problems?
For sure. Great synopsis, by the way. That was Meetup a handful of years ago. We then migrated to Hive and Hue, but we felt like we needed an upgrade from that. It was still really slow, and also much harder for non-engineers, non-SQL proficient folks to get at data. And we looked at a few different products. Tableau is another great one, by the way, but we felt like Looker was better for us. So the way that we're organized, we are what I guess they'd call in the industry a matrix organization. So engineers, for example, have a discipline home. I guess it's similar to Spotify's structure, but we probably don't have as fancy names as Spotify has as far as guilds and that kind of thing. But we each have each engineer has a discipline team. So if I'm a back-end engineer, I'm probably on the core engineering team. If I'm writing more front-end web stuff, JavaScript stuff, I'm probably on the web engineering team, and so forth. So each engineer has a discipline team that they're a member of. And, honestly, we have full-stack engineers who kind of sit with one team more than the other, but attend meetings and lunch and learns and meetups about all. But then, each person on our product and engineering and strategy team is on a product team as well. So we have engineering, which is obviously engineers. We have product, which includes our product designers and our product managers. And we also have a strategy team that includes our data scientists and our strategists, who are the probably most frequent consumers of our data through Looker. Now, the way that we're set up with data scientists and machine learning engineers and data engineers is probably a little bit interesting too. We're still pretty small. We still have a team of about 10 that's really focused on data. A lot of companies who, frankly, are probably bigger than we are, or maybe philosophically have a different way of handling this, and that's really cool too. A lot of companies will split up the research and development part of machine learning algorithms, training algorithms, doing research, seeing what's working, what's not, and then kind of having those really smart PhD type people, right, throw things over the wall to a production quality engineer to build into the product. And we don't have that difference here. The only difference that we have engineers who work on the data team, and those engineers typically work on machine learning stuff, data engineering stuff, as far as getting that machine learning into our product, and also data warehousing and data pipeline stuff. So that's the piece running on the infrastructure to get all of that analytics tracking data as quickly and as well as possible from our users into Looker, right? The faster that feedback loop can happen, where we can launch experiments and we can launch split tests, and our business folks can see that data in Looker, the faster we can make decisions and the faster that we can make our product better. So our engineers actually work on all three of those things, and we tend to attract engineers who love working on those things, but might love specializing in one of them for 6 months, a year, 2 years, whatever that may be, but not thinking of those things as siloed different departments. Now, we also have, within our strategy team, we also have a lead data scientist and a data scientist, and it's that person's role not to do production engineering and not really to do the machine learning engineering. They work mostly with whoever happens to be working on the data warehouse, the data pipeline, and building a little bit of infrastructure that does the Looker connection to our system. So they really own Looker as a product. They own the integration of Looker for the business team. And even much more importantly, they own the strategy and the implementation around all of the different dashboards and queries and easy ways of getting at data that our teams have built into Looker, which has really been awesome and revolutionary for us for the exact reasons that you mentioned. Which is we can make decisions much faster and things become, a lot less siloed in decision makers' hands.
I want to go back to a question about the moving to the AWS side of things for where you're putting your monolith or the main business logic. You mentioned wanting to move towards more of a stateless architecture. What are the places where there was a lot of state in the business logic, and how have you factored that out?
Yeah, that's a great question, and probably the implementation details of those are frankly probably things that I don't know.
Okay.
But from what were some of the most stateful things, we have a lot of old jobs and cron jobs that are run, and those do really anything you'd expect a regular job to do. A lot of them relate back to our subscriptions. Some of them relate back to aggregating. For example, one of them is personal calendar, right? Everyone gets a notification or email and a customized personal calendar of all the meetups they're going to for that week. So we've, because of our scale, a lot of those things run asynchronously in the background and are processed that way. And we have a lot of jobs that do those types of things. And that's the biggest area where we saw state being managed within our apps and the most kind of kittens there. So we've actually we've taken those out of our cloud formation template infrastructure entirely, and instead of, we wanted to do this quickly. Next year, in a couple of weeks, we'll start some of the process of actually getting rid of a lot of those things. But what we've done for now, we've just isolated them. So they're not part of our cloud formation templates. They're not really part of our infrastructure as code environment as much as all the other stuff. We've isolated them into their own servers We're using OpsWorks, which is just the managed chef stuff, to manage them with much more custom scripting. And the isolation has really just allowed us to make sure that we're doing everything that we can as stateless as we want to, and that, say, 80% of our infrastructure can automatically scale. We can make use of Phoenix server philosophy and let things crash and burn and just kind of spin them up as stateless servers again. So for us, it's been more about isolation at this stage in the game than actually changing the way the software works. Next year, so this year was all about getting all of these things running in production. So getting our new data pipeline, our AWS infrastructure up, getting our new backend service-oriented architecture up and running, getting our new web platform up and running. We launched new apps that were rebuilt as well. It was really all about getting everything up and running. And that's been the first year of our big replatform effort. This next year is going to be about the health of a lot of those things. So really focusing on what things can we as an engineering team do to change our architecture, to change some of the services that we're using, to change some of the frameworks that we're using, to make all of those things work better in a cloud environment. And we have a short list of some things that we want to change over the next year, and are going to start banging away at some of those.
Has the process of moving to multi-cloud, has there been some trade-offs there, like having to build proficiencies in the organization with AWS and GCP? Because those are very different technology stacks.
Yeah. So, I guess so, but we look at it. So we're about 70 engineers. So we have enough engineers to have interest, but also we have enough engineers to so that we have redundancy. If people, if some people want to learn AWS, some people want to learn GCP,
Sure.
Having some backup there. But honestly, we thought it was a little bit bold for us to make this decision, but we really saw how different use cases manifested differently on the two cloud platforms, and we really saw some big advantages for us to doing it that way. And we thought that there would be a more difficult learning and ramp up, and actually people learning both have kind of made them better, right? So our teams have prototyped on both, so they know a little bit about the other platform. But it's actually been really awesome and cool to see how much sharing between the two has happened. Amazon's way ahead in just the number of services that they offer. Google, we think, is ahead in developer love, right? Like kind of quality, how much a developer loves using a service, and that's been really cool to see those differences. And when we're coming up with trying to solve new architectural problems, it's really cool to see people who have experience with both talk about how Amazon or Google has solved that problem, and I've just seen us learn a lot more from building on both. We didn't have much cloud in-house experience at all. I hired a director who had done this before and had a lot of experience on Amazon, but we thought it would probably serve Meetup best if we worked hands-on both platforms for X number of months, years, and got the best of both. And we probably will make a decision in the future to go all in on one, maybe. But we didn't feel like we could.
Some strong conviction.
I know, really strong there. But we didn't feel like we needed to or could make that decision without actually using them as Meetup would need them right away.
Sure.
So it's been somewhat liberating, and we've learned a ton by building on both.
Sure. You mentioned Kubernetes, I think. Where are you using Kubernetes?
So in our, we are using Kubernetes as really central container management for all of our new backend core platform, which is a service-oriented one. I'm hesitating saying microservice. It probably is. It certainly is by common definitions. That word just comes with a lot of jargon around it. I'm not a jargony type person. But we've really found Kubernetes and that using it as a container management platform has made all the things that we want to do in a quote unquote microservice platform really baked in. We have to.
So this is on the AWS side.
No, sorry, this is on the Google.
The Google side.
So Kubernetes is baked into Google's cloud platform, right? So when you can install Kubernetes and run it on Amazon. Amazon also has their own container service. We ended up building a pipeline on both. And we just loved how baked in Kubernetes was into Google. You didn't even have to think about it. You didn't really have to configure everything. It just worked. And for software engineers who want full operational ownership and don't want to have to think about it that much, and also like have a real interest and desire to get as deep into the stack as they can. But really the way GCP worked with Kubernetes was just, it seemed so easy for us to get up and running. And the feature set we didn't find prohibitively lacking, at least not yet for us. So we're pretty excited to be using it.
Well, okay, so most of the shows I've done about Kubernetes focus on the use of Kubernetes as nice hosting for your production services. So if you're running a service like Gmail, for example, Gmail has all these traffic fluctuations and it's made up of all these different services, and you want these services to be able to scale up and down elastically. So it makes sense to have this platform where you're scaling up containers and scaling down containers in response to different production loads. But you're talking about using Kubernetes as the underlying compute architecture for the data processing side. So for both. So what you said is right. And I guess what I was trying to get at is you can do that on Amazon and you can do that on Google, and you can be just as happy on either one. So we're not using Kubernetes for our data pipelines. So I was probably confusing there. The other thing, a separate environment that we've chosen Google for is our backend core platform, our new microservice platform, right? So we're slowly peeling away business logic and looking at the boundaries of our product and peeling away business logic from our monolith on Amazon. And we're deploying new services on Google. So over time, right, we might end up seeing less and less of our application on Amazon as we pull off of those off that business logic and deploy them on services on Google, right? That's what we expect to see, but that may not happen because technology and software is unpredictable. But exactly what you said is also what we're doing, right? The reason why we loved Google, though, is because it was so baked in to GCP that engineers didn't even have to think about configuring it and setting it up and how it would run. It just worked, and there was a very easy learning curve to get from from hey, you're building a new service to hello world service in production. And we spent a few months of our engineering effectiveness team that's building our pipeline on Google for our microservice architecture. They spent some time getting from onboarding a team to them being able to deploy a hello service application in an hour. So we're pretty psyched about that. Is the process for stripping off a service from the monolith on AWS to standing up a partitioned version of that service on GCP, have you standardized that process organizationally? And Do you have a model for like what order you're stripping off services into microservices from the monolith? Or maybe you could talk about that.
Yeah, man, are those all great questions. So we got some great advice from a guy named Greg Pass, who was a former CTO of Twitter, which really stuck in our heads, which was look for the biggest bottlenecks in your monolith and start with those, right? Really practical, really strategic, really smart. And that's been a kind of a guiding force for how we do it. On the other hand, though, we're really early in this process. So the first thing that we wanted to do was really just prove out our architecture worked. We wanted to go through the process a couple of times end to end, launch a service in production, prove out the architecture, see where things sucked, where we had to make some things better. So we picked a couple of different services to do that with. We picked a planned service, which is part of our subscriptions infrastructure, mostly because our subscriptions business logic had been the most newly refactored. We had the most testing there, the most unit testing for sure. It was pretty modern. It was almost all Scala. It fit, we're doing a lot of code gen tooling in our core platform. So it really fit well with us being able to go from having nothing on our new platform to getting our first service up and running. So that was one of them, and then another one was a strategic bottleneck. We were looking at we have a notification system that's built in house. We were looking at moving that, and we were having scaling issues. We were having some scaling bottlenecks. So looking to move that, breaking it off as its own service as well. We also, where we've evolved, I guess the best way to answer that now, this first year has been more about experimentation and trying to get the right services up and running so that we learn the most, right? Our subscription service that we wanted to get up and running, versus our notification service, they use very different kinds of architectures. Theoretically, one is much more suited for probably a SQL data store. The other is much more suited for a key, name value, key value type thing, maybe even a pub sub type thing. So we really wanted to learn the most and get things up and running the most. For next year, what we're planning on doing is doing a two-step process for all of our existing code. For anything new, we're advising, and we give our product teams a lot of empowerment, a lot of autonomy, but we're advising them to build anything new on the new platform, right? That seems like a no-brainer strategically. But for our product teams who are doing a significant amount of work with business logic and code on our existing platform, we're doing what we're calling domain packaging. So we're essentially breaking off all of the pieces of business logic for a certain part of our product into different domains. And that's our first step to organize them into services, because once we've done that, once we can do that within the monolith in a really good organized way, it's far, far easier to then take those domains and refactor them onto our new platform and deploy them as services. So we've domain packaged our we call it chapters, which is a legacy thing, but essentially meetup groups. We've refactored a lot of the business logic around creating meetup groups and creating events around those meetup groups. And that served as a great model. That was some of the oldest code that we had in the monolith. And that served as a great model for how to do domain packaging for all product teams going forward. So we're providing a couple of our principal engineers are going to be working with different teams, embedding with them, providing guidelines for how to do that. And it's another experiment for us. We think it's the right thing to do. And in the next 6 months, we'll see if this domain packaging thing really gets some traction with the different product teams and how it works for them. So we're pretty young in this process so far.
Software Engineering Daily has 20,000 engineers listening Monday through Friday. If you are hiring, or if you have a product that you would like to get into the hands of engineers, send me an email, jeff@softwareengineeringdaily.com. This podcast is sustained by the advertisers, and if you would like to become one, or even if you're just curious and you want to learn more, send me an email, jeff@softwareengineeringdaily.com. Thanks for listening. We've been talking mostly about the technical process of being a CTO. I'd love to talk some about the managerial process and what you are doing day to day. The role of CTO is very much about delegation, and I think some engineers who move into management roles, this is one thing they have trouble with or they want to know more about. Do you have any tips for how to become a good delegator?
Yeah, let's see. Well, I think it really starts with, I think of it less as delegation, but more as empowerment. And this is my own in my own head. So this is very subjective. But when I think of delegation, I think of bosses, for lack of a nicer word, bosses giving work to other people to do, right? That's kind of like classic delegation. I think to be, probably to be a senior engineer and to be an engineering manager who's running a team that's really in the weeds day to day and building stuff, breaking tasks down into smaller ones and delegating them is really, really important and essential, and you have to do it well. I think once you get to a CTO level, typically my direct reports are really high-performing senior people to begin with. And for me, it's about empowering them to do their jobs better and better. And it's really about listening to their ideas, listening to their architecture ideas, listening to their organizational ideas, listening to how they want to do things in the future. And, I started at Meetup a little over a year ago now, and none of these replatforming projects were underway then, really. But, I firmly say none of them were my idea going into the role at Meetup. I sat down with every single engineer on the team one-on-one when I started in my first 4 weeks. So I was in a lot of meetings, if you can imagine that. But I asked a few open-ended questions and really just listened to how people wanted to improve our architecture, how they wanted to be more productive, how they wanted to do things faster, how they wanted to make things higher quality from their perspective, and organize that into a strategic roadmap and plan and vision, but then just figured out ways to empower a lot of the engineers here who had the most passion, experience, skills, vision themselves to go do these things, right? And to set up the organizational structure, to set up the right alignment. I'm a huge fan of how Spotify does things, and their videos that they've published, their animated videos are great. But I'm a huge fan of viewing it that way, which is as a leader, you want to align on why you're doing things strategically. Why are you doing things, and what are the big things you're doing? But then let your teams and like you were saying, delegate to the teams or delegate to the people or empower them to have autonomy in how they're doing it, and the order and the roadmap and the specifics, right? So I view it a lot more as, what roadblocks can I remove from people? What organizational things do they need to really make an impact? What visionary things do they maybe need to get kickstarted to making that business case to then make an impact? How can I help them with those strategic business cases? How can I help them persuade others to follow their lead? How can I turn the biggest change agents, the people fearlessly not afraid to fail in the name of failing fast and learning and not blaming and moving on and eventually, in my opinion, always innovating faster than those who are not fearlessly moving forward and unafraid to fail. How do I celebrate that from an engineering culture perspective? How do I remove blockers for them and roadblocks? And how do I help them gain, kind of a following and people who they can pair with and mentor and manage too? So kind of all over the place, but that's my take on it all.
Yeah, I've talked to some managers, engineering managers, and other technical leaders, even technical product managers, where they do this thing where in order to win the allegiance of the engineering team, to build legitimacy with the engineering team, sometimes they will just jump into an engineering project, or they'll do an engineering task, they'll fix a bug or something on their own, just so the observant engineers see occasionally, oh, this person actually jumped into the weeds and solved this bug. But it sounds like at the CTO level, maybe things are just so much more about people interaction than, and you're at this point a few levels removed from maybe the people who are direct engineers, so maybe you don't need to do that, that solidarity by example as much anymore.
Well, I think the innate philosophy is spot on, right? I think it's crucial for me and crucial for everyone who's on the engineering leadership team to, all hands on deck to jump into things when needed. But it's what are the best things for me to jump into? I used to be a coder 100% of my time. I don't do that anymore, and I haven't done that in 6 or 7, probably a little bit more now, years. And to be perfectly honest, that's not the most productive way for Meetup to spend my time. But I am absolutely very invested in when a team is having a problem, I'll jump right in there and try to help them solve it, not by coding, by maybe coming up with approach, maybe being the one to communicate a critical issue to the rest of the company or to our customer service team in a clear, concise, confident way that keeps them focused on the problem and doesn't distract them with anything else. So that that's an example as something as a CTO, I can get really into the weeds and really into the details and understand that stuff. The things that I jump into doing, because I think it is very important to do that, by the way, things that I would jump into doing might not be coding, right? It might be selling to our leadership team the business strategy for why we should do X, right? And really diving into the weeds of, well, how much is that going to save us in hard costs and engineering time, and come up with total cost of ownership formulas, and then go pitch something to the business owners of the team. So I think that sentiment's really, really important. But I think at the CTO level, just like you said, it's probably not fixing a bug. It's probably doing something more strategic, more communications focused, more business meets technology focused, maybe more process focused, or some kind of other blocker that at least me personally, I'm a better person to help overcome than maybe solving the defect type thing.
What I like about Meetup as a product is it's encouraging of people to meet in the real world.
Yes, we're Meetup.
Exactly. And, I heard, I was listening to a podcast interview yesterday, and it was with this, I think it was Thomas Friedman, actually, and he was talking just about, problems in the world, problems in the American economy, and he was saying that, the most dramatic health problem in the United States is not cancer, it's not heart disease, it's actually solitude and loneliness. And I think there is something there. I think there's, whether you want to draw a line between smartphone addiction and solitude, or just people being solitude because they've lost touch with people, Meetup is this nice product that allows for that. So do you, just to close off, from your vantage point of working at Meetup for a while at this point, How do you feel about the trends of socialization that you see?
Yeah, I mean, it's a great question, right? The election we just had, people were really split. It really split this country in two. A lot happened digitally for the first time in an election versus self-organizing in person. You see that across a lot of social issues these days, economic issues. And I truly believe that now more than ever in human history, do we need to do things in person with one another, things that we love, things that we want to do, things that make us happy, things that help us learn. Yeah.
Just to interject from a personal standpoint, this is something I have noticed over the last year and a half since starting this podcast and working alone in solitude for much of my day, is how caustic it is for the human soul to just be sitting alone in a room for the majority of your day, and how damaging it is on your sense of reality. And our how addictive our computers have gotten. It pushes us in that direction.
Yeah, I mean, you said it yourself. That's your feeling, right? You feel that every day. And we call, one of the things we have a name for here is the Meetup high, and that's that feeling that you get after you've gone to a meetup with other humans. You might know some of those humans, you might not know some of those other humans, but it's that feeling that you get when you're there, when you're doing, when you're playing the violin for the first time in 10 years, when you're learning to run faster with your marathon training meetup, when you're at the tech meetup, learning about, some new JavaScript framework, and learning from someone else in a way that you couldn't have done on your own, right? Or being motivated, or just that community that forms around having regular meetups with people doing those things that you want to do more of in life together. And we see it all the time, and we kind of, we jokingly, not jokingly, refer to it as the Meetup high, because we go to meetups all the time ourselves, and we feel the same way. Similarly to how you described it, we see more and more that I think humanity needs this, and we're a very mission-driven organization. Our CEO Scott and CFO Brendan have founded Meetup and been here the last 15 years, and we feel like we have a stronger mission than ever these days to help people connect and do the things that they love, and build the community that comes out of that. So. Yeah, that's what we're doing.
All right, Yvette, it's been great talking to you. The time flew by, and very interesting architecture, great product. I love it, and it was a pleasure talking to you.
Great speaking with you, and thanks so much for having me on, Jeff.
Thanks to Symphono for sponsoring Software Engineering Daily. Symphono is a custom engineering shop where senior engineers tackle big tech challenges while learning from each other. Check it out at symphono.com/SEDaily. That's SYMPHONO.com/SEDaily. Thanks again, Symphono.